Hello everyone, here in this section we have triple integrals and cylindrical and spherical coordinates. So the cylindrical coordinates of a point in space are r theta z. Definition: cylindrical coordinates represent a point P in space by ordered triples r theta z, in which r is greater than or equal to 0. R and theta are polar coordinates for the vertical projection of P on the xy plane, and z as the rectangular vertical coordinate. Here we have equations relating rectangular xyz and cylindrical r theta z coordinates. So x is equal to r cosine theta, y is equal to r sine theta, and z equal to z. And here we have r squared equal to x squared plus y squared, and tangent theta is equal to y over x. Now here we have integration in cylindrical coordinates. Limit of s of n is equal to triple integral over d of f dv. It is equal to triple integral over d of f dz r dr d theta. Now here we have the spherical coordinates rho, phi, and theta and their relation to x, y, z, and r. Definition: spherical coordinate represent point P in space by ordered triples rho, phi, theta, in which number 1, rho is the distance from P to the origin, and rho is greater than or equal to 0. Number 2, phi is the angle, and phi is between 0 pi, inclusive. Number 3, theta is the angle from cylindrical coordinates. And here we have equations relating spherical coordinates to Cartesian and cylindrical coordinates. R is equal to rho sine phi, x equal to r cosine theta, and that is equal to rho sine phi cosine theta. Z is equal to rho cosine phi, y is equal to r sine theta, and that is equal to rho sine phi sine theta. Rho is equal to square root of x squared plus y squared plus z squared, and that is equal to square root of r squared plus z squared. And here we have integration in spherical coordinates, and this limit of s of n is equal to trivial integral over d of f of rho phi theta dv. It is equal to triple integral over d of f of rho phi theta rho squared sine phi d rho d phi d theta. Example: evaluate the cylindrical coordinate integral. We have triple integral r dz dr d theta. So z is from 0 to 7 plus 25 r squared. R is between 0 theta over pi, and theta is between 0 to pi. First, integrate with respect to z. So here is double integral r, z is from 0 to 7 plus 25 r squared dr d theta, and this is equal to double integral 7r plus 25 r cubed dr d theta. So integrate with respect to r, we have 7 over 2r squared plus 25 over 4 r to the 4th power. R is from 0 to theta over pi. Here I used r equal to theta over pi, and then integrate with respect to theta. So here we have 7 theta cubed over 2 times 3, which is 6 pi squared, plus 25 theta to the 5th power over 4 times 5, which is 20, times pi to the 4th power. Theta is from 0 to 2 pi. So using theta equal to 2 pi, and then simplify. Here we have 8, and here is 6, so I divided by 2. Simplify, so here we have 28 over 3 pi. So it is pi cubed over pi squared, it is pi. And then I have 32 divided by 4, on top I have 8. So 8 times 5, it is 40. and pi to the 5th power over pi to the 4th power. Simplified, we have pi. So here denominator is 3, and on top we have 28 pi plus 120 pi, so that is equal to 148 pi over 3. So this is our final answer for this part. Evaluate the following integral. We have triple integral of 36 rho cosine cube phi d phi d theta d rho. So here on this part, phi is between pi over 4 and pi over 2. Theta is between 0 pi and rho is between 0 and 1. Write cosine cube phi as 1 minus sine square phi times cosine phi and perform substitution. So use u equal to sine phi and du equal to cosine phi d phi. Then integrate. So here we have integral of 36p cosine cube phi d phi. It is equal to integral of 36p of 1 minus sine square phi times cosine phi d phi. And this is equal to integral 36p 1 minus u squared du. So here cosine phi d phi is du. And this is equal to, so integrate, we have 36p times u minus u cubed divided by 3 plus c for constant. Now write this result in terms of phi. So here's our integral, and so on this part we integrate, and we had 36p times u minus u cubed over 3. So instead of u, we're going to use sine phi. So on this part we have double integral of 36p times sine phi minus sine cube phi over 3. And phi is from pi over 4 to pi over 2. So here first using phi equal to pi over 2, and then minus phi is equal to pi over 4. And based on what we have here, sine pi over 2 it is 1, sine cube pi over 2 it is 1, sine pi over 4 it is the square root of 2 over 2, sine cube pi over 4 it is the square root of 2 over 4. Simplify. So here we have double integral 24p minus 15p square root of 2 d theta d rho. So here we have integral rho from 0 to 1, 24 pi rho. So this is same as p, but we're reading, in this case we have rho, and then minus we have 15p, and here we have 15 rho is 15. We have theta is pi rho square root of 2, and then we have d rho, and finally integrate with respect to rho. So this is equal to 12 pi rho squared minus 15 pi rho squared times square root of 2 divided by 2. This is from 0 to 1. So here rho equal to 1, we have 12 pi minus 15 pi square root of 2 over 2. So this is our final answer.